In this video, we're going to talk about how to do a polynomial regression, which is when we're testing for a nonlinear trend in our data. In other words, there's a relationship between x and y that we think might not be best represented by a straight line. Now, this is linear regression, but we can raise a regressor x to some power. Usually in psychology, it's just to the second power, which is a quadratic trend. And test for that to see if that's a better fit for the data and for the relationship between x and y. So here we have a data set called politics, where we are going to try to predict political knowledge based on one variable in particular, which is the amount of news that the person consumes in average number of days per week. So this could go from 0 to 7. It's 340 people in the data set. So let's go ahead and get started. Now the first thing that I'm going to do is actually unnecessary for what we're doing here, but you can see there's a lot of variables here. And I just want to point out that if you ever feel overwhelmed by your data set and you want to create a side data set for the purposes of running an analysis, you can do that pretty easily. So I'm going to just show you how we could pick out a few variables and make a version of the data set that's a little bit cleaner. So I'm just going to go here and I'm going to create a subset of the data frame. And I'm just going to call this subset Pol for politics. And it's going to be equivalent to the politics data set, but I'm only going to select certain variables. So I'm going to do this with the brackets. Anytime we use the brackets, we are selecting or deselecting certain things from a row or a column or a data frame. So in this case, we're selecting particular columns. And at first, we're not going to use any covariates, but I'm going to use age, education, and sex as covariates. So I'm going to include these as well as our y variable, political knowledge, and our x variable, which is news. So I'm just going to include these in quotes, separated by commas. So just to remind ourselves of the names, we have P, no, age, sex, and then news. So P, no, age, sex, and news. So I'm going to go ahead and run that. We can see we now have a data frame called Pol. Instead of 16 variables, we've only got 5 variables, but we do still have 340 participants. Let's go ahead and view that. And we can see it's a little easier to kind of see everything that we're going to be dealing with here. Now, for the first example of a polynomial regression, I'm going to check and see whether news has a nonlinear relationship with political knowledge. Now I can do this with the scatterplot function. So I'm going to quickly get a scatterplot. First we need to load the car data frame, package. And so that's loaded. And now we can use scatter plot. And we use this in a way that's similar to actually running the regression, where we put the y variable first, and then the tilde, and then the x variable. Then we have to indicate the data frame, which is Pol. Now there's some other junk in here. We can already see that it's predicting a curvilinear line, but we haven't actually run the regression yet. So the straight line here, it would be if we tried to run a simple linear regression with news as the x variable, p, no as the y variable. You can see that there is a curve in the trend, a curvilinear trend here, and that we're not doing a great job of predicting those dots with this straight line here. So in the next video, I'm going to show you how to get a slightly cleaner scatter plot with the polynomial trend using a very popular graphics package called ggplot2. So I will cover that in the next video. But for now, we're just going to do the regression itself. So, so this would be a polynomial regression with one regressor. So before we do this, we first have to center the x variable, which in this case is news. And as your book talks about, centering the variable helps prevent some problems that you get in polynomial regression, sometimes with high levels of collinearity. So centering or mean centering the x variable, let's put the word mean here, mean centering the x variable means taking every score on the x variable, which is news, and subtracting the mean so that the new mean is 0. And that reduces the collinearity. So that's a reason to do that when you're doing a polynomial regression. It's not a bad idea. So to do that, we are going to create a new variable in the pol data frame called news CTR. So that's a centered version of the news. And this is going to take, we're going to calculate this by taking each individual score on news and subtracting the mean of news. So we don't even know what the mean is. We could get it using a describe function or just asking for it. In fact, I'll do that right now. I'll just ask what the mean of pol news is. And we can see it's 3.31. Okay, so now what we're doing is we're taking each individual score. For example, the first person has a news score of 2.5, so that's a little less than average. So we're going to take that 2.5 and subtract 3.31. Then R will do that for every single score and create a new column, which is the centered version of this variable. Okay, so we now see that there's a 6th variable in the pol dataset, and we can see that for this person here, and in fact the second person as well, because they were below average, we have a negative centered score for them because they're below the mean of 3.31. How much below the mean are they? 0.81. You could see a score that's above the mean is going to get a positive centered score. But we didn't even have to get the mean in order to calculate this mean center because we're just giving R the formula to do that. Okay, so now we're ready to run the regression. And I'm just going to call this mod 1, as I tend to do. And we're using the linear model function as we have been all semester. And we are predicting p knowledge, or trying to estimate p knowledge, model it, based on news center. We're using the centered version that we just created, plus a squared version of news center. And to do that, we don't have to create a new variable that is the squared version. We can just tell R to include the squared version of that. So what we've got here is that the I function is basically just telling R to leave this alone. Don't mess with it. Just do what I say, basically. So we don't have to think too much about that. It's just so happens that it doesn't work to build in this squared version unless you include this I here. I stands for ignore. So it's kind of ignore your normal rules. Don't worry about it. R, just do what I'm telling you to do. What I'm telling you to do is to take the centered version of news and square it. This little caret here says raise it to this power. So raising this to the second power is squaring it. And our data is pol. And so we can run that. Now we've got that model waiting for us to get a summary of it. So we have, looks like we have 2 variables in the regression, but we really just have one variable, but we have both the linear trend and the non-linear or quadratic trend. And both are significant, so it seems like we have both a linear and a nonlinear trend. But what this means is that with this significant nonlinear trend, that we are going to predict political knowledge better by including a curve than forcing it to be a straight line. We don't know how much better. We could actually ask for the squared semi-partial correlation, and that would tell us how much more we're getting. We could also run this without. So if I wanted a model 0 that was just a simple linear regression, we can see that without the nonlinear trend, the nonlinear portion, that we were able to predict about 3.3% of political knowledge. But once we added it in, that went up to about 6.3%. So an increase of not quite 3%, which is, we know that increase is significant because this is significant on top of the linear trend. We could compare these models. We could ask for the exact amount of R-square change, but we don't. For the purposes now, we know that this is significant, and like I said, in the next video, we will show how to get a graph that more cleanly shows this nonlinear trend. The last thing that I want to do is just show you that this is easily doable with covariates as well. So if we are including 3 covariates, which were age, sex, and education, then we would want to do this in 3 steps. So step 1, we will predict P knowledge from the covariates, which are age plus education plus sex. The model or the data is from Paul. And we can take a quick look at that. In other words, how much do age, education, and sex together predict in terms of political knowledge? And it turns out they predict quite a bit. We're not going to go into interpreting each of these. We've done that kind of thing before. But we can predict almost, well, somewhere between 29 and 30% from those additional covariates. So the question is, does news consumption actually add to this prediction? So in step 2, what we'll do is we'll do what we did before, which is age plus, sorry about that, plus education plus sex plus news. And we're going to use the center version. Data equals Paul. So that's step 2. Run that. Take a look at step 2. So this is, okay, so what happened here? Oh, I didn't put a tilde there. I put a plus sign. So that's, I think, what was going on here. So let's fix that. So we run that. Now it's fine. Okay, so now we have the 3 covariates in step 1, and we knew that they, as a set, were predicting a significant amount of political knowledge. News by itself, the linear trend, was not significant. It's not quite below 0.05. So there's no significant linear trend above and beyond the covariates. But what we're really interested in is, do we increase our predictive value by including the non-linear trend? Age plus education plus sex plus news center plus news center raised to the 2nd power. That's step 3. Let's take a look at that. Now we see this goes up from 0.30 to 0.3188, and you can see that because everything shifts around when you add new variables, we can see that new center has now become more significant, but also we have still a significant nonlinear trend. So even after accounting for age, education, and sex, news consumption has a nonlinear relationship with political knowledge. What that exactly looks like, we're not sure. This graph over here is without the covariates. But we're not going to really worry about that. We know that we have a significant nonlinear trend, and as I said in the next video, we'll talk about how to actually get a graph that shows us that nonlinear trend. If we wanted to, we could certainly compare these 3 models. So we could do ANOVA, step 1, step 2, step 3, and we can see that the linear trend did not increase predictive power significantly above and beyond the covariates, but the nonlinear trend did significantly increase the explanatory power of political knowledge above and beyond the linear trend and all the covariates. You could ask for the exact changes in R-square. We've done that. I won't bother with that right now because this video has gotten long enough, but that's just to show you that you can definitely do a hierarchical regression, include covariates, and still go about your business testing to see whether or not there's a significant nonlinear trend above and beyond the linear trend.